rotation of axis, we can do which example now? Okay, so you can do example 5. Example 4. Which one? Okay, yeah, example 5. One which has two squares. X squared minus the root of x, the root of 3, xy plus 2y squared is equal to 1. So to rotate, you need the equations. The equations are that we discussed that day. Solution. So we are saying x prime, moving from x to x prime. So x is equal to x prime cos theta minus y prime sin theta. And then y is equal to x prime sin theta plus y prime cos theta. Then the angle, we can use tan 2 theta is equal to b over a minus c. So if we start with the angle, so b is the negative root of 3, a is 1, c is 2. Remember, we are getting from the equation ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. That's where we are getting this from. So a, the coefficient of x squared, b, xy, c, y squared. So this will give us a negative root 3 over negative 1, which is positive root 3. So if tan 2 theta is positive root 3, so we're talking of tan 2 theta being positive root 3. So which angle gives us root 3 on the tan? So this will require that you should don't forget the angles. And we had a very good way of remembering the angles, especially the special angles, where you have, if I have 0 here, I have 30, I have 45, I have 60, I have 90. You can use the table or you can use the triangles. So if, maybe we use the table, and when we use the triangles. So this one, here we have 60, here we have 60, here we have 60, then we have 2, 2, 2. Then when you cut it in between, if we cut it in between, then we'll have a right angle triangle with 60 here, with 30 here. So what was 2 now has become 1. The other one is 2, 2. So to get the other line, we do 2 squared minus 1, which will be 3. So it becomes the root of 3. And then we are talking of tan. So then that will give us root 3. Remember, tan is opposite over adjacent. So if we go for 60, opposite will be root 3, adjacent will be 1. So we get root 3. So that 2 theta is equal to the angle 60 divide by 2, we'll get the angle theta to be 30. Now, if you use the triangle, it becomes very, very nice because you have found theta here. Then you take it to x. What is x? X prime cos 30 minus y prime sin 30. Giving us x prime cos 30. Cos is adjacent over hypotenuse, so it is 1/2. Because we are getting this from SOHCAHTOA. Then minus y prime sin 30 opposite over so there's a mistake here. On cos, cos 30 is adjacent of hypotenuse, so the adjacent will be √3 of hypotenuse 2. Then minus y prime sin 30 is opposite of hypotenuse. So this can be written as the √3 over 2 x prime minus half y prime. Then y is going to be, now we have already known what sin theta and cos theta are, so we just substitute. So when you say sin theta, you get half x prime, plus when you say cos theta, √3 over 2 y prime. We have to substitute these in here. The easiest substitution, according to me, is you first get x squared. What is x squared? So you multiply √3 over 2 x prime minus half y prime multiplied by √3 over 2 x prime minus half y prime. This is going to be 3/4 x prime squared minus 2, because we're going to get 2 of them. When you do this one times this one, and then this one times this one, you get the same thing. So there will be 2, and then that is √3 over 4 x prime y prime, and then plus 1/4 y prime squared. Simplify 1 here, 2 here. So we have 3/4 x prime squared minus √3 over 2 x prime y prime plus 1/4 y prime squared. Then from there, we go to the middle one, xy. So say xy is, or you can even put the √3, the minus √3. So that will have minus √3 x. X is the √3 over 2 x prime minus half y prime, and y is half x prime plus the √3 over 2 y prime. So we have negative √3, waiting for the expansion inside, which is √3 over 4 x prime squared, and then plus 3/4 x prime y prime, and then minus 1/4 y prime x prime, then minus √3 over 4 y prime squared. Then we distribute this one now. So we'll have So if we look at these are the same. It's y x prime x y prime. So the denominator is equal, so you just subtract the numerator. So 3 minus 1 will give us 2. So we're expanding now with this. So we get minus 3 over 4 x prime squared when you multiply root 3 times this root 3 there. And then here, remember, we have 2 in the numerator. 2 over 4 is the same as 1 over 2. So we'll have minus root 3 over 2 x prime y prime. And then the other now becomes plus 3 over 4 y prime squared. So what we've done is we added this first and got 2 over 4, which is half. So we got half x prime y prime. Then multiplied by the negative root 3. So I have to get negative root 3 over 2 y prime x prime. Like that. Then now, we still need 2y squared. So let's do 2y squared. So we have 2.
So sorry, the previous. All right, thank you.
Okay, so we have 2. So these equations, they need to be taken care of very well. This is x. This is x. And this is y. Okay, so now I'm picking y. Half x prime plus root 3 over 2y prime. So half x prime plus root 3 over 2y prime multiplied by half x prime plus root 3 over 2 y prime. That is what you're supposed to get. Okay, yes. Then we expand. So get a 2 here. Then we'll have x prime squared over 4 plus the root of 3 over 4 x prime y prime plus the root of 3 over 4 x prime y prime plus 3 over 4 y prime squared. So just to emphasize, if you're multiplying root 3 by root 3, you get 3 alone. So this simplified to, so the 2, because what we have here, okay, it's okay. So we just simplified because I've already simplified some of them here. So we'll send the 2 inside. So get x prime squared over 2, because the 2 will just be cutting the denominator here. Then we have 2. When we add this one plus this one, we get 2 root 3 multiplied by the 2 outside becomes 4 root 3. So the 4 will cancel and will remain with root 3 x prime y prime, and then plus 3 over 2 y prime squared. So when we get to the equation, remember the minus root 3, I've already used it. So we'll just get them and add. So we'll add throughout. Starting with the first one. So 3 over 4 x prime squared minus root 3 over 4. Is it over 4 or over 2? Over 2. Over 2 x prime y prime. And then plus 1 over 4 plus 1 over 4 y prime squared. So we're done with this one. Then we come to the next one. Minus 3 over 4 x prime squared. And then minus root 3 over 2 x prime y prime. And then plus 3 over 4 y prime squared. Okay, the other one is here. This one here. So plus x prime squared over 2 plus root 3 x prime y prime plus 3 over 2 y prime squared is equal to 1. So we add now. Okay, so let's start with the common denominator for x prime squared. I think it will be 4. So let me use a different color here. So we start with this one. And the common denominator is going to be 4. And then we get 3 x prime squared minus 3 x prime squared plus 2 plus 2 x prime squared when we get this one here. And then the next, we'll go to the middle one, minus, the common denominator for this one is 2, so we put 2 down. So we'll have minus root 3 x prime y prime. And then the next one is here, also minus root 3 x prime y prime. And then this one here, plus 2 root 3 x prime y prime. And then we get to the y. The common denominator also is 4. So we'll have y prime squared. And then here, plus 3y prime squared. And then here, to be plus 6y prime squared is equal to 1. So here we have 3x prime squared minus 3x prime squared, and that is 0. So we remain with 2x prime squared over 4. Then here the whole product, x prime y prime is 0. So this will be 0. The middle part will be 0. So we forget about it. So we got the next one. We get y, that is 4, 10. So we have 10y prime squared over 4 is equal to 1. If you, by the time you are done completing, expanding, you find that you still have the x prime y prime product, then whatever you're doing is wrong. You have to recheck you've made a mistake somewhere. Because the angle that we use to rotate, it's a must that it will take away the x prime y prime combination. We just remain with the independent x prime y prime. Very crucial. So now what do we have? Now we have x prime. For the first one, we have x prime squared over 2 plus, that is 2 can go into 4. So we put a 2 down. Then the other one, 2 can go, but it will give us, that is 10 over 4 there. So 2 there, 5, 2 here, 2. But it has to be in the denominator. So it will be y prime squared over, then you reciprocate, so to write it in the denominator as 2 over 5 is equal to 1. That's the standard. And this one is an ellipse. Oh, even before you start solving, you may wish to check if what you're having is an ellipse. Remember how we check? So that you just know that, okay, whatever I solve here, I should arrive with this. So we say that b squared minus 4ac. So what is it? B is the root of 3. Squared minus 4. A is 1. C is 2. This is giving us 3 minus 8, which is equal to -5. And we said if b squared minus 4ac is less than 0, then you have an ellipse. So what you have is less than 0, so we have an ellipse. So as you solve, you know I should arrive at an ellipse, the equation of an ellipse. So at least you have a clue, so that when you get here, you don't get surprised or you start doubting whether it's supposed to be an ellipse or a parabola or what. No. Then sketch. So last time we sketched on this, we just named these same lines. Now today, these lines will remain X, Y. Then we want to sketch on the new ones. On our rotated lines. So this becomes X, so it will be X prime. And then another one becomes Y prime. Remember, the angle is 60, so it doesn't have to look like it's cutting in between. In between is 45. Now our angle is 60. If I'm not mistaken. Oh, the angle is 30, so it has to be a bit lower. Okay, I was thinking it's 60. So it has to be a bit lower. So for 60, for 30 to be here. So for 30 to be here. Okay. So this is X prime, and this is Y prime. We just bend a bit. And then A, so as you can see here, A squared is equal to 2, the bigger one, so that A is equal to the root of 2. So the we have the root of 2 here. This is the vertex and the negative root of 2. It's also the vertex. So the other one's the root of 2 over root of 5. So those, so I can have a sketch. So here where it cuts, it's the negative root 2 over root 5. And it's a positive root 2 over root 5. It's not clear. So it's a positive root 2 over root 5. Then from there, we get C. So C squared is equal to A squared minus B squared. So get 2 minus 2 over 5, giving us 5 down. That is 10 minus 2, which is 8 over 5. So C is going to be the positive root 8, which is 2 root 2 over the root of 5. So root 8, when we say root 8, it's the same as the root of 2 times 4. So root 4 root 2. So it becomes 2 the root of 2. If you don't know this, you can just write root 8 over root 5. That's all. Then the other side, I will have the negative 2 root 2 over the root of 5. That is how this one comes out on the rotated axis. So let's take questions. Any questions?
Yeah.
It's clear? Okay.
Yeah.
Okay. Okay, so I think that's enough for rotation. Then we can talk about the question 6 in the tutorial sheet. Which says, given the parametric equations and parameter intervals for the motion of a particle in the xy plane, identify the particle's path by finding a Cartesian equation for it. Graph the Cartesian equation. 1. I are given x is equal to cos t, y is equal to sine t, where 0 is less or equal to t, which is less or equal to pi. Then you have to sketch this after you find the relationship. So you can sketch using the parametric equations given, or using the Cartesian that you find. So how do you find the Cartesian equation here? You know, when you're given cos and sine, the easiest relationship that we appreciate is the one where it's identity. It's the identity cos squared x plus sine squared x is equal to 1. This is what we always want to have. So in this case, we are given x to be cos, y to be sine. So if we square cos, we also square sine, we'll get 1. Now, because cos is x, so we're having x squared. Sine is y, so we'll have y squared is equal to 1. This is a circle. So because it's a circle, we can easily sketch it. Okay. So its radius, its center is 0, 0, its radius is 1. So you just sketch a circle. Now we're taught from 0 to pi. So just sketch the upper part. It would have gone the way down if it was from 0 to 2 pi. So now this one is just from 0 to pi. So of course its direction is this anti-clockwise? Yeah, anti-clockwise. This is clockwise. And this is the reverse. This is anti-clockwise, yeah. So that's how the purpose of the t is to tell us that it doesn't have to go around up to 2 pi. It's just half a circle. So that's how you put it there. Then you can talk about the next one. The next one is the same thing. X is equal to cos 2t. Y is equal to sine 2t. So again, if we square cos squared 2t plus sine squared 2t, this will give us 1. But cos squared 2t is just the same as x squared. Sine squared 2t is just the same as y squared, giving us 1. Another circle. But this time around, the circle goes from 0 to pi. It's the same thing. To look just like this, the same one. Okay. And the third one, maybe that's why I have to think a bit. The third one has x is equal to sec squared t minus 1, and y is equal to tan t. and it runs from negative pi over 2, which is less or equal to t less or equal to pi over 2. Now here we have a relationship. The identity that we have for tan is of which nature? Let's see. Tan squared x is equal to sec squared x minus 1. Do we have this identity? Okay, no. So the one we have as identity is of this form. Tan squared x is equal to 1 plus sec squared x. This is what we have. So tan squared x minus sec squared x is equal to 1. So if you've forgotten, you can use this guy to derive such equations. So for tan is sine over cos. So you divide by cos squared x, you divide by cos squared x, you divide by cos squared x. So this will give us this will give us 1 plus tan squared x is equal to sec squared x. Yeah, this is the identity. So that's also forgotten. So it is 1 plus tan squared x is equal to sec squared x. Okay. So when you're given sec and tan, you need to retrieve the relationship and then look for it. So what we've been given here is something like tan squared x is equal to sec squared x minus 1. If we take this one on the other side, so we'll have that one. But x has been given that as sec squared minus 1. Y has just been given as tan t. So this means that we need to square y so that we get x. So then it becomes what type of a graph? This becomes a parabola that is facing to the right, like this. And so it's been given that it's from negative pi over 2 to positive pi over 2. So it's just something like this. So you go up 90, you go down 90. So we know that in the actual sense, when you're having the whole 0 to 360, you require that the other guy down becomes negative. It becomes positive 3 pi over 2, which is 270. But if you have to use the negative 90, it means that you're moving this direction, same steps, and this direction, same steps in the negative sense. So you can use 270 as negative 90. So that's how your sketch will come out. So the question of parameters always depends on the identities that are there. So you don't have to forget the first identity. Okay, so we'll be logged out. And then we can log back quickly so that we do the polar coordinates now.